So, question 8 says, show that the triangle with the vertices blah, 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 and blah, blah is right angled. How do we do this? Of course, we start by drawing our Cartesian plane and plotting the points. So let's go ahead and do that. We plot our points. And the point here, P, which is 6 minus 5. Let's imagine this is 6 on the x-axis and minus 5 on the y-axis is about there maybe. So we can put that point there, P, which is what? 6, comma, minus 5. Nice. Minus 5. Oops, no, let's close that. Or let's just use, a regular notation. I don't know why I'm using square brackets here. So let's use the curved brackets, or parentheses as they say. Then we have Q, which is minus 1, 1, minus 1 here, and 1 maybe there. So we have it here, Q of what? Minus 1 and 1. Nice. And finally we have, let's erase this guy and that guy so we can keep our draw board neat. We have minus 2, minus 3. Maybe minus 2 is there, and minus 3 is maybe there. So we have this point here. Let's put it there. We have R, which is what? Minus 2, minus 3. Parfait. Finally, all we do now is we just connect up the points. We connect up the points. So we have here QR, and then we have QP, and then finally we have, sorry, no, that was RP I just did. And finally we have QP. So QP, let's use this orange here for the QP. Nice. Okay, now if we can establish, first of all, let's shrink this so that we have space to actually do the math. I know I drew it so big. Okay, no, that's too small. Let's go a bit, oh la la. Let's go a bit bigger. Let's go that big. Perfect. Now if we can establish that this one, QP, well, let's name them first. Here we have QP, then we have RP there, RP, and finally we have RQ there. I'll put it inside RQ. So if we can establish that RQ squared plus RP squared is equal to QP squared, then we have it. QP squared. And I'll get you started on this one, and then I'll leave it for you to do. So all we need to do is figure out, let's say, like RQ. How do we figure out the distance for between any 2 points on the Cartesian plane? Hopefully you remember this. Like if you have, let's do a separate one. So here, imagine we have this point, which is A, and it's the point 1, 1. And we have here B, which is the point, so here, if this is 1 and 2, 3, and let's say 4, that's the point 4, and then 3, right? 4, 3. How do we find this distance? This distance here, AB. To find AB, we just have to figure out, or notice that we can make AB the hypotenuse of a triangle, this triangle. And therefore, we can write something like this. We can write that AB squared is equal to this distance here between the y's plus this distance here between the x's. Let's do the x's first. So for the x's, this x is 4, this x is 1. So we say 4, subtract 1, and we square that, plus, and then here we have 3 and 1. So 3, subtract 1 squared. So this is just like c squared equals a squared plus b squared, right? So here's our a and here's our b, and our c is this one. And then we can find AB like that. So when we do this, then we would end up with AB squared is equal to 9 plus 4, which is equal to what? 13, right? And then if we wanted, we could find AB. So we could find the square root of 13, and that would be AB. But as you'll see here, we don't even need to get to the square root part. We can keep it as AB squared. So let's get back to the question. All right, so let's start with RQ squared, right? First of all, let's make a bit of space. So let's do a partial erase and then a whole erase there. Good. Okay, so we're using the red color to do RQ. And we have RQ. Remember what we did. We said that we subtract the x's. So we subtract the x's. So we have maybe minus 2 subtract, no, sorry, not minus 2. Minus 1 subtract minus 2, right? Minus 1 subtract minus 2. Or we could have done minus 2 subtract minus 1. It comes out the same. So minus 1 subtract minus 2 squared plus, and then we do the y's. Minus 3 subtract minus 1. Or should we go the same direction? Okay, let's go the same direction. We go 1 minus minus 3. So 1 subtract minus 3 squared. Okay, and we can simplify this to be what? Minus 1 plus 2 squared plus 1 plus 3 squared. And then we can simplify this further to be 1 squared, which is just 1, plus 1 plus 4 is 4 squared, which is just 16. And finally, we simplify that to 17. Okay? Then we do the RP. RP. So let's add RP now. Okay, now I'm confusing you because this stuff is getting mixed up with the graph. So let's move it away from the graph by putting this line here. Okay, so don't get it confused with the graph. All right, now let's do RP, and then I'll leave you to do QP and find the final answer. So for RP, we need to find the distance between this and this. So again, we do the squared. We do the square of each difference. So the square of the x difference is 6 subtract minus 2. So no, why am I using blue? I should be using green. So we do 6 subtract minus 2 squared plus minus 5 subtract minus 3 squared. So minus 5 take away minus 3 squared. And that would give us, we have 6 plus 2 squared, which is 64, plus minus 5 plus 3 is minus 2 squared. So minus 2 squared is 4. So here we end up with 68, right? We'll just bring the 68 down. And all of this should be equal to, so when we add these together, we'll get, let's see, we'll get 85. And that should be equal to 85 on this side. So what you're going to do now is do the same thing with QP, but, no, there's no but. You do the same thing with QP, and it should simplify at the end to 85. And it simplifies, then you are good. Okay, so I leave the rest to you for homework. Okay, for this next question, we have to determine the fourth vertex of a parallelogram given 3 vertices. So I recall that there was an algebraic solution to this one, and I don't like that solution. So we'll just use here the geometric one, because the algebraic one is much harder and it's not worth the time. So we use the geometric one, and to do that, we start by doing a good graph. So let's do a good sketch. Let's use red for the sketch. So we do a nice sketch. Let's do it here. Okay, nice. Is that good enough? Yes, that's good enough for me. And we put our points. So now you've already started. We have A, which is 4, 3. So we have 4. So maybe 1, 2, 3, 4, right? So 4 is about there. And 3 is about, let's say, there. So this is our A, which is 4, 3. Nice. And then we do B, which is 2, minus 1. Where should B be? B is 2 minus 1. 2 is maybe here, and minus 1 is maybe there. Okay, so we have B here, which is 2, minus 1. And then we have C, which will be minus 2 and 1. So we have minus 2 maybe there, and 1 is about there. So we have C here, which is what? Minus 2 and 1. Nice. And so our D, if this is going to be a parallelogram, starting with A, we should go like this. A, B, B, C, and C, D somewhere there. Okay, so we can put our D there. Let's put the D, let's put it in this blue here. So this blue here, where should I put it? Where should I put it? Let's put it maybe right there. Okay, that looks good to me. This is our D. D. And we don't know it. Let's call it the points, what should we call it? Let's call it I, J. I and J. Let's write that I better. I, J. Now, we're going to join up our points. Join up our points. Here we have AB. And then we have BC there. And then we have CD. Finally, we have AD or DA. Doesn't look quite like a parallel. No, I think it's good enough. I was going to say it doesn't look quite like a parallelogram, but I think it does. So this is parallel to that. And these two are parallel to each other. Parfait. Let's continue. So here's the main idea for the geometric solution. Basically, you use the properties of a parallelogram. For a parallelogram, based on the fact that the lines we've just said are indeed parallel, then the distance from B to A, the x distance from B here to A, should be the exact same as the x distance from C here to D. And so we can just figure out that here the distance from B to A is 2 to 4, which is just 2. And so from C to D will be minus 2 plus 2. So this one here will be 0. So just minus 2 and then move forward by 2. So 0. And then for the y, actually, should I do the y? Maybe I won't do the y. I'll start the y and then I'll let you finish it. So for the y, the distance from B to A here should be the same distance as from C to D in terms of the y-axis. So B to A, we have 2 there. Sorry, no, minus 1 there and 3 there. So that would be 4. And so what would be the distance from C to J? We'll do minus 1 and then we add 4 to it and we get to the y. Okay, so that's the intuition. Now let's see how we can write it in a way that your teacher will give you the points, because if you don't write it in a good way, they might not give you the points because they'll say you didn't explain it well. All right, so let's move that a bit and let's write it in a nice way. So here's how we're going to write it. We're going to say for parallelogram, I'll just write parallelogram like that, A, B, C, D, comma, the line, let's say BA, let's put BA here in pink. So BA, the x of BA, that is the x component of the BA vector, is equal to the x component of the CD vector. So CD here, I'm just formalizing what I was saying in the picture. CD here, the x component. And we know that the one for BA is, we already calculated it, is 2 to 4, which is 2. So we'll move here by 2. And we know that this is equal to 2. It's equal to 2. Okay? And therefore we can write that I, for D, for the point D, that I is equal to minus 2, and then we add this vector. This is the vector 2 that we just figured out here. This is what this thing, BA, B to A, and the x direction is 2. It's the same as C to D in the x direction, that's 2. And so to find I, which is the x of D, we're just going to take the minus 2 here of C and move forward by 2. So we're taking here the minus 2 here of C, and we're going to add 2 to it. So let's do that. And we add 2 to it. So we do minus 2 of C there plus 2. And that will give us 0, which tells us that this I here is 0. So we can write comma 0. And then you need to find the J. I'll leave you to find the J by just doing the same thing. So you write this, but instead you write the y component. So the y component of BA, like that, should be equal to the y component of CD. And then you finish. All right, so the rest of that is homework. Good luck. So the question says the point P lies on the line with the equation blah, 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 and it is 5 units from the point blah, blah, blah. Determine the coordinates of P. How do we do it? This one is actually quite tricky. It took me a while to figure it out. But let's go ahead and do our this guy. What do you call this thing? A coordinate plane, our Cartesian plane. And what should we do first? Let's put the point Q. So the point Q, which is minus 2, 0. So that'll be here, maybe minus 2, 0. Here's our point Q. Okay, and Q is minus 2, 0. And we know that the point P is 5 units away from Q. So you can imagine sort of like a circle that goes 5 units away from Q. And P could be anywhere on this circle. but it has to cross this line here. So let's draw the line first, actually. So our line is x plus 2y equals 8. X plus 2y equals 8. And let's rewrite that as a point slope form. Or not point slope form, slope intercept form. So we have 2y on one side is equal to minus x, because we move x to the right side, minus x plus 8. And then we can rewrite that as y is equal to minus half x. So we're dividing both sides by 2 now, plus 4. And in this form, we can draw this equation because we know that the 4 is the intercept. So 4 maybe will be about here, let's say, and that's the intercept. And minus half is the slope. Any negative slope means it's going downwards. Minus 1 is going exactly at 45 degrees. Minus half is slightly less than 45 degrees. So it'll be maybe something like that. Okay, so that's our line, and the line is what? Y is equal to minus half x. Minus half x plus 4. Perfect. So let's extend it a bit. Okay, so now we can imagine then that this, our Q, that we're trying to find a point on this that is 5 units away from Q. So we can imagine here that this would be 5, and this would be our point P. Or maybe there's probably another one in that direction, and that would be our point P. But we'll just focus on the first one, and probably the second one will come out of our mathematics. So let's go ahead and shrink this so that we have space to do the mathematics. So here's the main idea. The main idea is that we are going to use this distance here to compute a kind of distance formula for P. And then we will use the fact that P lies on this line to find the final answer. Okay, what I said probably did not make any sense. What we'll do is we're gonna call the point P. We're gonna give it an x value, we'll just call it x, and a y value y. And we'll just start working the math. So here's the idea. We know that the formula for a distance, the formula for this distance here, QP, you can say QP squared is equal to, let me draw a line. Let's use blue. We have this here, and we're gonna have that one there. Let's use orange. So QP squared is going to be equal to this thing squared plus this guy here squared, right? So what is this thing here squared? This thing here squared is going to be the x's here, x minus 2. So this x here minus 2. So the distance between this guy here and that will give you this distance. Hopefully that makes sense. Okay, so let's do that. So we have now that QP squared is going to be equal to, so we're trying to find, what am I doing? We're trying to find, yes, this here, which would be x minus 2, x minus 2 squared. Plus, and we do the same thing for that blue part, but that's the y-axis. So the y-axis, now we have y minus 0 squared, which we can just write as y squared. Okay, and now what do we have? We're going to have this. It's going to be the same as x plus 2 squared. So let's just change it there. X plus 2 squared. And hopefully you know how to expand x plus 2 squares. It'll come out as x squared plus 4x plus 4. All right, you FOIL it. Remember what foiling is? You FOIL that. Okay. And then we have still plus y squared. Plus y squared. All right, keep changing the colors. So here we have a plus in black. All right, now the magic is the following. Since we already know QP, and QP is 5 squared. So we can rewrite this here as just 25. Okay. And we can now use this pink line to substitute in for one of these values, either the x or the y. What do I mean by that? Let's see. So basically we have this equation here, and this equation contains the x and the y for P. But we know that at the point P is on this line, which means that at the point P, y is always going to be minus half x plus 4. So we could take the y here and substitute in minus half x plus 4. and we square that, and we would only have x's then left in this equation, and then we could find the final solution. Or because y has this minus half, and I don't like minus half, we can do the same thing for x. So let's do the same thing for x. So we can, so here we had 2y equals minus x plus 8. We can rewrite that as, well, let's go back to the beginning. Here's the beginning. X plus 2y equals 8. So we have simply that x equals 8 minus 2y. You see that? 8 minus 2y. Just move the 2y over. So now we can substitute that in everywhere that we see an x, which is these two places. And we can get a final answer. So then we can have now 25 is going to be equal to, x. Instead of x, we're going to write 8 minus 2y. So we write 8 minus 2y squared. 8 minus 2y squared. Plus 4 times 8 minus 2y. 4 times 8 minus 2y. So I'm just subbing in 8 minus 2y for the x's. And then we have the rest of it. Plus 4. And then plus y squared. I can keep that one in blue. Okay. And then now we can solve this part. So this again, we're just going to FOIL it. FOIL. First, outer, inner, last. And when we do that, we will end up with 64 minus, let's see, was 2y times 8 is 16y, and you multiply that by 2, so minus 32y, plus 4y squared, and then plus 8 times 4 is 32, minus 4 times 2y is 8y, of course, plus 4, and then forget about this blue, I'm changing it to orange now, plus y squared. Okay, and all of this is equal to 25. And now what we can do is we can put together all the ones that have the same coefficient. So we have 4y squared here, and we have y squared there. So I can put a rectangle under those, so I remember those. And then we have the minus 2y and the 8y, those are together. And then the ones that have no y term, we put there as a circle. Okay, so I will stop at this point, and I'll let you finish it. So when you simplify this whole expression, then you will get a quadratic equation that has a y squared term and a y term, and you can solve for y. And once you solve for y, then you plug it into any of these equations here, or this one, and find x. Okay, and you should have there are two pairs of points that would satisfy this equation here. Okay, I will leave you to do that for homework. Bye-bye. So for question 11, we have 3 points, and we're asked to determine the equation of the perpendicular bisector of line segment AB. That is the perpendicular to AB through the midpoint of AB. Okay, all right. So let's go ahead and draw the points as always. So we draw a Cartesian plane and try to make it straight. It's good enough for me. Nope, good enough for me. And we have now the point A, which is 2, minus 3. So we have here maybe 2 here and maybe minus 3 there. So this is our A, which is 2 minus 3. And then our B is going to be 6, 1. So maybe 6 here, 6 there, right? Yes. And 1 there. So 1 here. So we have 6, 1, which is our point B. And finally, we have the point C, which is minus 6 and minus 3. So over here maybe, and minus 3 will be there. So here we have minus 6. Let's put it here, minus 6 and minus 3. And this is, of course, the point C. Nice. Okay, now it says determine the equation of the perpendicular bisector of the line segment AB. So let's draw that line segment AB here. So here's AB. Oops, AB. Okay, so what is the perpendicular bisector of the line segment AB? Perpendicular bisector is perpendicular, so this is a perpendicular. All these pink lines are all perpendicular to AB. Which means that their slope, if the slope of AB was, let's say, 2, if the slope of AB is 2, then the slope of the perpendicular bisector would be you flip the fraction and flip the sign. So we can imagine 2 to be a fraction 2 over 1. So we flip it and we end up with half, and we change the sign from plus to minus. So if the equation of this one, of the slope of this one is 2, then the slope of these ones would be minus half. Okay, that's just to remind you what it means to be perpendicular. And now what is the bisector? The bisector needs to pass through the middle. So it needs to pass through the middle, the midpoint. And how do we find the middle? The middle will just be the average of the x's and the average of the y's. So let's see how we can do that. Let's leave in this perpendicular bisector. So here is what we think is going to be the final. Oh no, that's not too good. Doesn't go down the middle. Here's what we think will be the final perpendicular bisector. And we want to find the equation of that line. So our first thing is to find the slope of AB. So slope of AB. You agree? This point here, we want to find its slope. So its slope is going to be rise over run. So the y's 1 and then minus 3, that will be 4, over the run 6 minus 2, which is 4. So our slope here is 1, right? Okay, yes, perfect. Which means therefore that the slope of the perpendicular bisector, let's call the perpendicular bisector, I don't know, let's call it PQ or whatever. Oh no, let's just call it the line P. So slope of P is going to be equal to, let's leave it in pink. We take 1 and we flip the fraction, which will just give us 1, and we flip the sign, so we change it to minus. So this has a slope of minus 1. That's very nice. Now the next thing we need to find is the midpoint of the line segment AB. So midpoint of AB is going to be equal to the average of the x's and the average of the y's. What does that mean? You see this point here? If we draw like a triangle, right angle triangle, you can see that that point is going to be the middle of here, the middle of this line here, and the middle of this horizontal line there. Okay, and what's the middle of the vertical line? It's going to be the average of 1 and minus 3. Okay, so we're going to do the average of 1 and minus 3. So we take 1 and we add it to minus 3, and we divide it by 2, and that's our average. Okay, so the x, so we say AB sub x maybe? No, not AB, sorry, midpoint. Let's call it midpoint. Let's call the midpoint M. So M sub x, no, but that's confusing with the slope. Let's call it MD. MD sub x is going to be equal to 1 minus 3, which is minus 2, over 2, which is equal to minus 1. And then MD sub x, sorry, sub y, is going to be equal to, we do the same thing but for the y's. We have, oh no, what I just did was the y's, sorry. So what I just did was the y, and then now we do the x. We do the x, and the x of course would be, here we have 6 and we have 2, so that will be 6 minus 2, or 6 plus 2 I mean, over 2, which will give us 4. Okay. So the average of this point here, which is x equals 6, and that point here, which is x equals 2, the midpoint of that is going to be 6 plus 2 over 2, which is 8 over 2, which is 4. And it makes sense that this is going to be x equals 4. If this is 2, that's 4, that's 6. Okay, nice. So now we have the x and the y of the midpoint. So basically we can figure out the equation. So midpoints of AB then overall will be equal to, so midpoint is equal to 4 comma minus 1. And it kind of looks like that, right? 4 here and minus 1. So it looks right. Alright, let's try and neaten out our piece of paper so that everything makes more sense. Alright, now what we need to do now is find the equation. The equation of which line should we find the equation of? Let's find the equation of the pink line. How do we find the equation of the pink line? We need the slope, and we already have the slope. The slope, or m, is this thing, minus 1. We've figured that out. And we need any point on the line. So the slope plus any point on the line. Do we have a point on the line? Of course we do. We have this middle point, which must also be a point on the perpendicular line. So what we're going to do is plug that into y equals mx plus c, and we find a c. We find an intercept. So we have y equals mx plus c. So we plug in a y from the midpoints, which is -1. So we have -1 is equal to, we plug in our slope, which is also -1. We plug in our x, which is 4, right? 4 plus c. So then we have -1 is equal to -4 plus c. And therefore we have that -1 plus 4, which is 3, is equal to c. So then our intercept then, so our intercept is 3. Okay. So then if our intercept is 3, we can rewrite this equation. Therefore, equation of, let's call it bisector, is equal to y is equal to, no, let's not say is equal to, let's say colon, y is equal to, and then we have our m, which is our slope, minus x, minus 1x, or you could just write minus x, plus 3. Okay, so that's the equation of the bisector. Let's shrink that. Equation of the bisector, we have that now. So we make it a bit smaller. Okay, and we're almost done. Let's put that in a nice box so that we don't get confused here. This is one set of problems here. Perfect. And this was the first thing we found, the slope. Then we found the midpoint, and then we found the equation. So we did here 1, then we did 2, and then we did 3. And are we done? Oh, we're done. Okay, yes. So it says determine the equation of the perpendicular bisector. So there's the equation. So we're done. But of course, now we need to do the bonus. How do we do the bonus? The bonus says hence or otherwise, determine the coordinates of the center of the circumscribing circle to triangle ABC. So here's the idea. Here's our triangle ABC. Let's complete the triangle ABC. So we have this here, and then I'll do it in gray as well. So there's our triangle. Now here's the idea about a triangle. Here's the thing about a triangle. Good enough. Is that if we take any two bisectors in a triangle, say like this one we've taken. Let's say we take this one. That is the bisector of this line here. Wherever they meet up there. That point where they meet is a center of a circle, and if we can draw a circle from that point that will touch all of the axes. So we can draw a circle that will look something like this. Alright, and it'll touch all of the axes. And there's only one such circle. There's only one circle that can touch all of the axes exactly like that. All of the vertices. And that circle, we know its midpoints by taking two perpendiculars through the through any of these lines. So let me give you the intuition for that. So here's some triangle here. And then imagine now we did two bisectors through this. So here's one bisector. So I'm just cutting this thing in half, and I cut this one in half at 90 degrees. So here's our center there, and I cut this one in half as well at 90 degrees. It doesn't look perfect, but you can see they all meet at one point. And if I draw the distance from this point to any of the vertices is going to be the same. So I can draw a circle that touches each of those vertices. Actually, I'm not sure if the distance is always the same. But in any case, I can draw a circle from this center here that will look, let's say, something like, in this case, something like that. It's not a perfect circle, but you see the idea, right? So this is the center of that circle. And it touches there, touches there, touches there. Let's try one more. So I'll draw some other crazy looking triangle. You can test this, it always works. Let's draw this triangle here. Let's try this one. Okay, and what is the bisector? The bisector of here would be like here, right? So through the middle and 90 degrees. And the bisector of, let's try this one, would be through the middle and at 90 degrees. And we end up at here. Now here I can draw from there. I can draw this. Oops, I don't know. Not good enough. Can do that circle there. And it touches there, it touches there, it touches there, and it comes around. It's going to be a very big circle, but you can see that I can draw such a circle. Alright, so that was just a proof for you, a visual proof that if you do the perpendicular bisectors of any two sides of a triangle, where those bisectors meet gives you the center of a circle which circumscribes that triangle. So I'm going to leave this for you to do. All you have to do is find the equation. We found the equation of this line here, and that is this thing here. Y is equal to negative x plus 3. What you have to do now is find the equation of this other line. Or if you want, you can try the equation of this line here. But they all meet at the same place. And once you found those two equations, then you're going to equate them to each other. Let's say you find this equation to be, I don't know, y is equal to 10x plus 2. What you're going to do is say that wherever they meet, they're going to have the same y. And so you would say something like 10x plus 2 is equal to minus x plus 3. And then you can solve for x. And once you solve for x, then you can solve for y. And you have the center of that circle. So I leave that for you to do as homework. Good luck. Okay, so for the glory, let's look at this for the glory one. It says determine the value of a given that the triangle with vertices blah 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 is isosceles. For an isosceles triangle, you know, any two sides are going to be equal. Two or more sides must be equal. So if we can establish that, that will allow us to solve this question. So of course, let's start by drawing our Cartesian plane. So we have something like that, and let's do our points B and C first, since those are complete. So B is 2, 3. So here we have maybe 2 here, and maybe 3 there. So this is B, which is 2, 3. Put the point. And then we have C is 5, 4. So here we have, if this is 2, then this would be 4, and maybe this is 5 here. So we have 5. And if that's 3, then maybe 4 is over there. And this is C, which is what? 5, 4. Actually, let's change the color of that. So, oh no, let's leave it in the same color. C is what? 5, 4. And finally, we have A, which is A7. So we do the 7 first, of course, because that's the only one we can do. And 7 is maybe, if this is 4 and this is 3, then 7 will be, let's say, here. And it'll just be a line. So we don't know the x, we just know that it has a y of 7. So we can just do a kind of line there. You can dot it. Okay, and A could be anywhere here. But we can kind of guess where it will be based on the fact that the triangle must be isosceles. So I've solved this before this video, and there are actually 3 possible points. But for now, we just pick one. So let's imagine now that, let's move this. Move that a bit. Let's imagine now that the point A is, let's say, here. A, and this is the point A, 7. Okay. And therefore, if we put that there, then what we're going to assume, here's our line BC. We'll call it BC. And then here is going to be our line AB. And finally, we have over there our line AC there. So what we're going to assume, this looks kind of equilateral, which is confusing, but let's start out by assuming that AB and BC are equal. Okay, so we're just going to assume that AB and BC are equal. Let's make some space here. Okay, so we're going to assume that AB is equal to BC. Just to start out, let's just assume that AB is equal to BC and see what happens. BC. So if AB is equal to BC, we need to calculate the distance AB. How do we do it? We just use the distance formula. So we subtract the x's, we square them, and that plus the subtraction of the y's squared will give you AB squared. So actually, it'll help us now if we just write AB squared is therefore also going to be equal to BC squared. All right. So how about, let's start with AB squared now. AB squared is going to be equal to A minus 2 squared. So A subtract 2 squared plus 7 subtract 3 squared. 7 subtract 3 squared. Let's make sure the subtract is clear there. Okay. And this would be what? This would give us a squared minus 4a plus 4 plus what's 7 minus 3? That's 4. 4 squared is 16. Okay, and we can simplify that to give us a squared minus 4a plus 20. And if that is equal to b squared, we can solve, to bc squared, we can solve also for bc squared. So let's solve for bc squared. And this is an actual number, so we wouldn't have any letters left, any variables. So we would have here 5 take away 2. So we have 5 take away 2 squared plus 4 subtract 3 squared. 4 take away 3 squared. 4 minus 3 squared. And that will give us here 3 squared, which is 9, plus here 1 squared, which is 1. And so this overall will be equal to 10. And we can move this over, right, to give us a squared minus 4a plus 10 is equal to 0. So we have here a squared minus 4a plus 10 is equal to 0. And then we can try to solve this for a. Okay, so we're almost done with this first assumption. Okay, let's try this one. So we have a and a. Is there any number that can multiply to give us 10 and add to give us minus 4? The numbers that multiply to give us 10 are 5, 2, and 10 and 1. And none of those can ever add to give you 4 or minus 4. So this we cannot factor in this simple way. So then we can try factoring it by completing the square. Hopefully you remember how to do this. To factor by completing the square, we're going to rewrite this as a squared minus 4a. And we shift the 10 a little bit to the right. And then what we do then is we take this minus 4, we divide it by 2, minus 4 over 2. And that term will give us what? Minus 2. We take the minus 2 and we square it. And that'll give us 4. And we're going to add 4 and subtract 4. Add 4 and subtract 4. And all of this is still equal to 0. And all this stuff that I did here is kind of by the side. So let's put it off to the side. Alright, we proceed. So now, the reason we just did that is because this stuff here, these first 3 terms, can simplify to give us what? A minus 2 squared. So here we had minus 4 over 2 gave us minus 2. And this minus 2 is basically what we fit in here. And you see that if you expand this stuff, you will get these things in the purple brackets. So expand that and you see you get that. Anyways, and outside we have minus 4 plus 10, which is what? Plus 6. Plus 6. And all of that is still equal to 0. It's equal to 0. And now we can move the 6 over. So we end up with a minus 2 squared is equal to, and I'm changing it now to just all green, minus 6. Okay? And we take the square root. A minus 2 is equal to the square root of minus 6. Ooh, now that looks like a problem. Plus or minus root 6. Right? Plus or minus root minus 6. Because you can't have roots of negative numbers, right? At least not at this level of math. You can't do that. But anyways, we finish it. So we say a is equal to root negative 6 plus 2 or root or negative root negative 6 plus 2. Okay, hopefully that makes sense. So those are 2 possible values of a. And those don't exist. There's no such thing as a root negative 6. You can only have square roots of positive numbers, like 6 or 7 or whatever. So basically, there are no real solutions here. So we can write here, no real solutions. No real solutions. Which means, if we go back up there, that when we made this assumption that AB was equal to BC, that does not work. All right? So it doesn't work. It doesn't work. But we had to try it anyways, because otherwise you would never know. So what we do now is we're going to put all of this to the side. So let's see if we can shrink this a bit. Move it over here. And then we will grab it all and shrink it even more. Ooh la la. No. What happened? No, please. Oh, Lord. Okay, we're almost done. So we put that off to the side. Assume AB equals to BC did not work. Let's try another one. So let's try. So we did. Where's my pen? We did AB equals BC, and that didn't work. Let's try now. BC equals AC. So we try a different one. So now we say assume that BC, which is in orange, is equal to AC. And if that's true, then BC squared should be equal to AC squared. Right? And if we know this now, then we can calculate BC and we can calculate AC in terms of A, and we see what comes out of it. So BC, we already did it here. Remember? BC squared, so no need to do it again. We know it's 10. And that is equal to AC squared. This we haven't done before. So we need to do again the subtraction of the x's. A minus 5. So we have in that color there, we have A minus 5 squared plus 7 minus 4 squared. 7 minus 4 squared. And that will give us, if we expand this, we end up with what? A squared minus 10A plus 25 plus 7 minus 4 is 3. 3 squared is 9. Right? And then we can simplify this further to give us A squared minus 10A plus 36. No, plus 34, I mean. Oh la la, what is that? What's going on? Plus 34. Okay? And that is, of course, still equal to, on the right, still equal to 10. 10. So now we can bring the 10 over. We bring the 10 over, and we say minus 10 here. Okay? Minus 10. Plus 10. Okay, so this would go away. And our final thing would be what? 0 is equal to A squared minus 10A plus 24. Right? A squared minus 10A plus 24. And now let's try again to see if we can solve this as we can factor it as a simple quadratic like that. So we have A, and we can ask what pair of numbers multiplies to give us 24 and adds to give us minus 10? I think it's minus 6 and minus 4. Okay, you can check it out yourself. Minus 6 and minus 4 work, which would then suggest that A is equal to 6 or A is equal to 4. Oh la la. So those look like they work. So it means that if we found here we're at the point A has an x value of A and a y value of 7. And we just found that the x can be 6 or 4. So let's see if that would make sense here. What would be 6? So if this is 2 and this is 5, then 6 would be around there. Let's say there. So that means the triangle would look actually like this. And it kind of makes sense here because this, you could imagine that as being equal to that. So that could work. And then for 4 would be about, if this is 2 and this is 5, then 4 would be about there, maybe. And so it would look like that. Okay, sure, maybe you can sort of see it. I know it's right because I've checked it before, but it is right. So here you can see that these and these would be the same. Okay, so that works. So now we have two possible solutions, 6 and 4 for A. There's one more solution. So let's shrink this one. Oh la la, go away. Shrink. And put it down over there. And we try our last solution. The last solution is the hardest. So here we've tried now. What have we done so far? We assumed that AB was equal to BC and we solved and we got nothing. Then we assumed BC was equal to AC and we solved and we got 2 points. Our last pair is that AC is equal to AB. Those are the last pair of possible sides with the same angle. So now we do assume that AC AC is equal to AB, right? AB. AB. And if that's the case, then of course AC squared would be equal to AB squared as well. I need to stop using so many colors because it slows me down. So we have AC squared here. Okay, nice. And we've already done all of this. We already know AC squared from here, and we know AB squared. So no need to do the math again. We know that over here, when we did AC squared, we got this, and then we got that, and then we got this. So we know that AC squared is A squared minus 10A plus 34. So we end up with A squared minus 10A plus 34.